Okay, so hi guys. So in this video, what we're gonna do is we're gonna look at this following problem. And it's basically composition of functions, but it is composition of rational functions. So we're gonna look at this example. It says, given f of x equals 1 plus x over 4 plus x, and g of x equals 1 over x plus 8, find f of g of x, g of f of x, f of x, and g of x. Okay, so we're first going to write our functions. So I always like to, kind of use different colors if that helps you. And it always helps me. I do know that on the test you can't really do that, but as long as you just do it slowly, if you don't have colors, just do it a little more slowly. So f of x is 1 plus x over 4 plus x, so, and g of x is going to be 1 over x plus 8, so give me a second, guys. Okay, so the first part of this problem is to find f of g of x. Now the way that f composited, so basically f composited of g of x is going to be f of g of x. So in this case, we're going to have f of the quantity g of x, and we're basically going to go ahead and plug in g of x in for x and f of x. So how that's going to look is it's going to be 1 plus, and anytime I have an x, I'm going to put a g of x there first so that you guys can see exactly how this is going, or how this goes, and then over 4 plus g of x. So I'm just kind of putting in step by step my information. And then from here, we are going to go ahead and do and then plug in 1 over x plus 8 for f of g of x. So, or actually for g of x, excuse me. So the way that it's going to look is going to be 1 plus, and we're going to put 1 over x plus 8, and then put an entire fraction, and then put 4 plus, and then 1 over x plus 8. Okay, guys, so basically, as you can see, the g of x kind of aligns with both of these. So we're just kind of plugging one function into another, and that's what composition of functions is all about. So now what we're going to do is from here we have, so now it's a matter of just simplifying this expression. We have 1 plus 1 over x plus 8 over 4 plus 1 over x plus 8. So now what we're going to do is get the common denominator. Clearly it looks like it's x because there's no other term when it comes to a variable. There's no other term that, is common. So this gives us x plus 1 plus 8 all over x over, and it's going to have a common denominator of x. And then it's going to be, so if we do the same thing for the bottom, we're just going to multiply x just like we did on the top. We're going to do the same to the bottom. So the way it's going to be is 4x plus 1 plus 8x all over x. And then from here, we're going to do some combining like terms. So we clearly have a 1 and an 8. So we're going to do x plus 9. So 1 plus 8 is 9 over x over 4x plus 8x. That's going to be 12x plus 1 all over x. So as you can see, this is kind of what we have here. So now we have a division of two rational expressions. So I always like to write it as a division of two fractions. So the way that this goes, you would basically do a over b divided by c over d is a over b divided by c over d, like this. So we're doing the same thing for this part. And now the last thing we're going to do for this first example is we are going to, or for this first part of this problem, is we are going to use the keep it, change it, flip it rule. Basically what you do is you keep this part, so we're going to keep the x plus 9 over x. You're going to change this to the multiplication, and then this is going to be flipped over. So we're basically going to flip it over. So it's going to be x over 12x plus 1. So that's keep it, change it, flip it. And so then if you guys have questions about that, please do look at my other videos over that. So we have something like this. So this, obviously the x's cancel out, and what we are left with is x plus 9 over 12x plus 1. Now let's say it wants you to find, I just want to add this extra part. Let's say it wants you to find the domain. So the domain of this function would actually be, or actually we're not going to do domain, never mind. I don't want to add more to this problem, but this would be our final answer. So I'll do domain and range in another video. Okay, so that's our first part. Now, so we're done with that. Now we're going to do g of f of x. So again, let me rewrite my functions. Okay guys, so let's go ahead and continue. So now our second part of this example, I already wrote it in the way that it's supposed to be. Basically g composite of f of x is basically g, so g of f of x, right? We're just plugging in. It's just like the last problem, except this time we're now plugging f of x in for g of x. So this is kind of the notation that we should have been given in class if you are in algebra. So let's see here. So we're basically going to say that this is equal to, so again, I'm just gonna grab this and then I'm gonna put it over here if it'll let me. Okay, so this is gonna be g of, and I know f of x is 1 plus x over 4 plus x, so basically I can do of 1 plus x over 4 plus x, okay? So now we're gonna put this stuff in for x in g of x. So how it's gonna go is like this. So again, basically we know that g of x was 1 over x plus 8, and now g of f of x is going to be 1 over f of x plus 8. Okay, and so from here, we're just going to put that in for that. So this is going to equal 1 over, and we're going to actually put 1 plus x over 4 plus x, and I want to put parentheses here and a bigger line here to denote that this is a division between a whole number and a fraction, and then plus 8, right? So now we want to go ahead and simplify this stuff here. So now we can kind of, you don't have to keep color coding here. We're going to have 1 over the quantity 4 plus x, 1 plus x over 4 plus x, and then plus 8, excuse me. And so, like I said, we need to we need to simplify this part. So this is really 1 divided by 1 plus x over 4 plus x. And I know that this is what that is, so it's kind of what this becomes. And this is going to be the same idea as the division of two fractions. You keep the first part, so it's just 1. You change this to a multiplication, so times, and then you're going to flip this over. So 4 plus x over 1 plus x. And then we're going to do 4 plus x over 1 plus x. So just know that there's a denominator of 1 there. And then plus 8. So now we need to go ahead and get the common denominator. So now this is our new expression. So now what we're going to do is we're going to say 4 plus x over 1 plus x. And I always like to put a over 1 here. So plus 8 over 1. You can try two things. The butterfly method, which you do cross multiplication like that, or you can do the common denominator. In this case, I'm just going to do the common denominator since it looks easier. So I'm just going to do that here. So our common denominator should be 1 plus x, since that's the only thing it can get to. And what you do to the bottom, you do to the top. So, oh, and by the way, actually it's not going to be right here, only here. So it should look something like this. And let me take this off. So then this would be 4 plus x over 1 plus x plus 8. Now you're basically multiplying this entire thing to 8. So you're going to do 8 times 1 plus x over 1 plus x, since it's, it's just 1 plus x there. So now we're just going to bring it all together. So 4 plus x plus 8 times 1 plus x all over 1 plus x. So now it's a matter of just simplifying this expression. We have 4 plus x, and we're going to do distributive property, plus 8 plus 8x all over 1 plus x. And now what we're going to do is combine like terms. So 4 plus 8, that's going to be 12. And then x plus 8x, that's going to be plus 9x here. So then this is going to be over 1 plus x. And so our answer is going to be 12 plus 9x over 1 plus x. You could also say 9x plus 12 over 1 plus x plus 1, excuse me. It doesn't matter how you write it as long as it equals the same thing. So this would be our answer for this example, for this part of this example. Okay guys, so now for this next example, we need to go ahead and do f of x. Now this is where it kind of gets a little hard, because now they're kind of the same function with each other. And again, what I do want to do, and what I am going to do here, is we need to remember to put 1 plus f of x in for x. So basically we're going to do f of x is equal to 1 plus, and it's going to be f of x over 4 plus f of x. Sorry, over 4 plus f of x. Yes. So now put this whole thing in for these two things. So we're going to have the following: 1 plus x over, let me actually do it this way, 1 plus x over 4 plus x over, and again, just making this very clear, as clear as I can, it's going to be over 1 plus 1 plus x over 4 plus x. So this is going to be like that. So just know that you're putting in this part in for this. because this is a little harder. So if I'm taking a little longer on this one, I'm really trying to explain it because it is a tricky one. So now we know that 1 is just 1 over 1. We have plus 1 plus x over 4 plus x. And then over, and we do the same thing on the bottom, 1 over 1 plus 1 plus x over 4 plus x. Now, there is a, give me a second, guys. Oh, I'm sorry. Actually, excuse me. This is a 4, not a 1. I'm so sorry, guys. It's supposed to be a 4. That's why I looked at it. I'm like, I thought it was going to be equal to 1. No, it's not. So now our common denominator, we can go over here. And we know that our common denominator, like I said, if it's an algebraic expression, it's just going to be that algebraic expression. So I'm going to make it 4 plus x on top and bottom here. And I'm also going to do that over here as well. Oh, and actually on the bottom, it's a little more difficult. So let's first look at the top. So the top is right here. So let me just kind of do that to the side. We have 1. It's going to be times 4 plus x over 4 plus x, and then plus 1 plus x over 4 plus x. So this is going to actually be the following: 4 plus x over 4 plus x plus 1 plus x over 4 plus x. So then this is going to be, let's see here. It's going to be 4 plus 1 plus 2x over 4 plus x. And this is going to be 2x plus 5, so 4 and 1 become 5, over 4 plus x. So we did that top part, and now we're going to do the bottom part. So, so now the bottom part, so again, the top part became 2x plus 5 over 4 plus x. So we're just going to put that up there. So this became 2x plus 5 over 4 plus x. And now we're going to do the bottom. So the bottom, this part, we're going to do it, let's do it over here. So we have 4 over 1 plus 1 plus x over 4 plus x. So now we're kind of doing the same thing as we did on the top, except it's going to be, there's going to be one tiny difference. So we're doing kind of the same process here. And now we have the following. So this is going to give me 4 times 4 plus x plus 1 plus x over 4 plus x. And now if I distribute, I will get 16 plus 4x plus 1 plus x. So, give me a second, guys. So it's going to be plus 1 plus x over 4 plus x. And then, let's see here. So these two are going to combine. So we have 17 plus 5x over 4 plus x. Okay, so like I said, on the bottom, we're going to have 17 plus 5x over 4 plus x. So that's what we're going to put over here. So like that. Okay. And now what we're going to do is just simplify this entire expression. So we have 2x plus 5 over 4 plus x divided by, and it's going to be 17 plus 5x over 4 plus x. And again, the way that you do this is you keep the 2x plus 5 over 4 plus x times 4 plus x over 17 plus 5x. Okay, guys. So then as you can see, these two are going to cancel out. And so we're going to be left with 2x plus 5 over 5x plus 17. Okay. Okay, guys. So, as I said, so then this would end up being our answer for this part, for this problem, for this part of the problem. So we're done with that. We already did... We did g of f of x as well. And now we're going to do g of x. So g of x, I hope it's a little easier, so let's do it. So now we have g of x. Okay. And now, like I said, g of x was 1 over x plus 8, I think. 1 second. Okay, guys, so g of x is 1, I'm sorry, g of x is 1 over x plus 8. So we're gonna do, I'm gonna try for this one to put it in kind of different notation, just color coding here. And I'm gonna denote g of x, I'm gonna put it in black here so that you guys can kind of see better what I'm doing. So this is actually going to be, it's going to be g, so really it's going to be like this, 1 over g of x, and then plus 8, right? I'm sorry, plus 8 like this. So we're basically putting this function into this here. So this will give us the following, 1 over, and we're going to do, it's going to be 1 plus x, I'm sorry, 1 over x plus 8, excuse me, then plus 8 again, so kind of like this. And now, the only thing to do here, and actually this is considered a, I want to say a nested fraction, I think is what they call it. Something like this. And so the first thing I'm going to do here is I'm going to simplify the bottom. So this one's like the last one where it's a little harder. So I'm going to simplify 1 over x plus 8. So I'm going to just put it over 1. And I know my common denominator, since it's a variable, I just multiply by that variable on top and bottom. And then this will give me 1 plus 8x over x. So I know that that's what's going to go in the bottom for this part here. Okay. And now, so what I'm going to say at the end, well, almost there, is the following. We're going to have 1 over, it's going to be 1 plus 8x over x, and then plus 8 over 1. So now we need to kind of, we're still not done with the left part here. We still need to simplify that expression. But since the numerator is 1, we're just doing the reciprocal. So we're just going to flip it over. This is going to be x over 1 plus 8x plus 8 over 1, right? And the reason why I know that is because it's 1 divided by c over d is equal to d over c, because keep it, change it, flip it. All right, so now the last part here is to do cross multiplication. And like I said, you can do it if you want, you don't have to. You can just do this instead. So just, you know, the common denominator is this. And then from here, we're going to do x plus the quantity. So we're just going to distribute that 8 plus, and it's going to be 64x all over 1 plus 8x. So now this is going to end up being 8 plus 65x over 1 plus 8x. And so that is going to be our answer for g of x, or g composited of g of x. Okay, guys, so that concludes this lesson. I really wanted to show y'all if kind of these examples in order to kind of show y'all a more, I would say a more difficult approach, or a more difficult topic when it comes to composition of two functions, because rational functions are usually very difficult because it involves a lot of fractions, etc. But that is going to be it for this video, guys. Thank you so much for watching, and also please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.